Welcome to next session in which we are going to cover the applications of derivatives in economics. In previous session, we have covered few formulas for elasticity of demand, average revenue, marginal revenue, etc. And in this video, we are going to cover the practical application of those formulas, right? So first of all, it is given on the screen that it is given that the demand function is taken as q and it is equals to 100 minus 2p minus 2p square, and we have to calculate the slope of demand curve and elasticity of demand when p is equals to 10, right? So if you remember, in our last session we have covered the formula of slope of demand, which is equals to dq divided by dp, right? And it is in negative. And when we have to cover the elasticity of demand, it is equals to minus p upon q into dq upon dp. Clear? So these are the two formula which we are going to apply today. So first of all, we have to calculate the slope of demand. So here it is given that the demand function, that is q, is equals to 100 minus 2p minus 2p square, this value, right? So we what we will do, q is equals to 100 minus 2p minus 2p square. Now next step, what we will do, we will differentiate with respect to p. Okay, so what I will get tq divided by tp is equals to derivative of this equation, right? So this further give me the value that the derivative of 100 is 0, being the constant term, and derivative of minus 2p is minus 2, and derivative of minus 2q square is minus, it is p square, sorry, 4p, right? So when we have to calculate the slope of demand curve, it is equals to minus dq divided by dp, right? So this is minus and minus of 2 minus 4p. So this gives me 2 plus 4p. So this is the value of my slope. This is the solution for a part. Now moving toward the next part, in which we have to calculate the elasticity of demand. So in that case, the formula will be elasticity of demand, and this is equals to minus p upon q into dq by dp. So the value of dq and dp we have already calculated. What we will do, we will multiply it with the value of minus p by q. We don't know the value of minus p right now, and q we are aware is that it is 100 minus 2p minus 2p square, and this we will multiply with minus 2 minus 4p, right? This value which we have already calculated. And if we open the brackets, it gives me minus 2p, it is plus 2p and plus 4p square. Okay, and it is divided by 100 minus 2p minus 2p square. Now it is given in the question that we have to calculate the elasticity of demand when p is equals to 10. So in this case, we will put the value of p as 10 divided by 100 minus 10 minus 2 into 10 squares. So it gives me 20. It is plus 20 plus 400. So here we have 420 divided by 100 minus 20 minus 200. And it gives me minus 120. So my solution will be, if I cancel the things, I will get 7 by 2 as my solution. So this is the value of elasticity of demand when it is given that p value of p is equals to 10, right? So let's take one more example to cover the concept. In this question, we have to calculate the marginal revenue product, right, which is equals to marginal revenue. And we have to calculate this if the value of P is 60 Q is equals to 100 plus 0.05 L square minus 0.0001 L cube, and the value of L is equals to 300, right? If you remember, the formula which we have covered for marginal revenue is derivative of total revenue, and the value of total revenue, how we will able to calculate it is by P into Q, and we know the value of P and we know the value of Q. So in this way we will able to calculate the value of total revenue, and then we will take the derivative of that value. So let's first calculate the value of total revenue. So it is equals to 60 into 100 plus 0.05 L square minus 0.0001 L cube. So this gives me 60 into 100, it gives me 6000, plus 60 into 0.05, it gives me 3 L square. Okay, and 60 into 0.0001 L cube, it gives me 0.006 L cube. So this is the value of TR. Now putting this value of TR in this formula of MR. So what we have to take, we have to differentiate with respect to L. Okay, so what I will get, it is equals to 6000, derivative of 6000 is 0, plus derivative of 3L square is 6L, and derivative of point double zero six L cube is 0.018 L square. Fine. Now it is given in the question that the value of L is 300. So now put value of L as 300 as given in the question. So 6 into 300 minus 0.018 into 300 square. So it gives me 1800 minus 0.18 into 9000, 90,000. And this gives me value as 1800 minus 1620, 1620. So this is equals to 180. So the value of marginal revenue product is equals to 180. I hope the concept of slope, MR, and total revenue and elasticity of demand is clear to you. Right? In the next session, we will continue with the few more practical questions related to cost.